Hi, now we are going to do a new chapter, light. In light, there are two basic things, reflection and refraction. First, we will see reflection and its laws. Laws of reflection. What is called a reflection? Suppose you have a medium. This is normal of the medium. Light is incident, reflected on the same medium. After incident on the surface, it comes back to the same medium. That is called reflection. The angle between incident ray and the normal, this is called normal. This is called incident ray. And this is called reflected ray. Angle between incident ray and normal, we call it as angle of incidence. Angle between reflected ray and normal, we call it as angle of reflection. The laws of reflection states that incident ray, reflected ray, normal, all lies in the same plane. Board is a plane. So incident ray, reflected ray, normal lies in the same plane. Incident ray, reflected ray, normal lies in the same plane. Second one, angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Correct? These are the two basic laws of reflection. Okay. Next, refraction. Mirror means it will reflect the light. Glass means refraction, partial reflection, but most of the light will be refracted. So you take a glass medium, this is called normal. As usual, incident ray. This is called refracted ray. This is air medium, this is glass. Air medium, glass medium. Air medium means air or vacuum, anything you can say. Light travels from rarer medium to denser medium. Air means rarer medium. Glass means denser medium. When the light is refracting from rarer medium to denser medium, it bends towards the normal. When light is bending from or deviating from glass to air, it bends away from the normal. This is glass. This is air. Denser to rarer medium means it is bending away from the normal. Rarer to denser means it bends towards the normal. As usual, angle between incident ray and normal, we call it as angle of incidence. Angle between refracted ray and normal, we call it as angle of refraction. Here also we have two laws. So, basic concept of refraction is light travels from one medium to another medium and it bends. Light is bending. Light is traveling from one medium to another. Reflection means it is reflected on the same medium. Here, two different mediums. two different paths. Velocity or speed of light is not a constant. We will discuss later. Two laws of refraction. Incident ray, refracted ray, normal, lies in the same plane. Incident ray, refracted ray, normal, lies in the same plane. And refractive index, some places they will use mu for refractive index, some places they will use n for refractive index. Mu is also a notation of refractive index, n is also notation of refractive index. Sin I by sin R. Ratio of sine of angle of incidence to the sine of angle of refraction is a constant and is called the refractive index of the medium. This is the second law. Right, ma? Here, angle I cannot be equal to angle R because light is bending towards the normal. So you cannot say angle of incidence and angle of refraction are same. No. Right. Next, spherical mirrors. Sphere, 2-dimension is a circle. In that part of this, we call it as a spherical mirror. Curved outwards, this is called concave mirror. Curved inwards, this is called convex mirror. Curved out, this is called silvered portion. Silvered. That means light is reflected on the other side. Light is getting reflected on the other side, this side. Here light is getting reflected on this side. So this is this part. We call it a silvered surface. Silvered part. Two parts we have. You might have seen the concave mirror and the convex mirror in your core classes. Concave mirror, curved outwards. Silvered surface, light cannot pass through. Other side, light will be reflected. Okay. Some basic definitions here. To draw a line, this is called principal axis. Principal axis of the mirror. This is AB. This is called center of curvature. Center of curvature. Center of curvature. This distance BC, AC, this and all, we call it as radius of curvature. PC is also radius. AC is also radius. BC is also radius. Radius of curvature, capital R. BC is equal to AC is equal to capital R. PC, that is also radius of curvature. When light is incident, say this is a concave mirror, this is the principal axis, this point we call it as pole of the mirror. Any ray passing parallel, this is called the principal axis. any ray passing parallel to principal axis after reflection pass through a point that is called principal focus, capital F. After reflection, it passes through the focus, F. The distance PF, we call it as focal length. The distance PC, we can call it as radius of curvature. Principal axis, principal focus, center of curvature, radius of curvature, focal length. Very important 5 points. Basic information. Normally, concave mirror means you will get a real image. Convex mirror means you will get a virtual image. Real image, concave mirror, virtual image, convex mirror. Meaning, concave mirror, when you take, this is principal axis. Reflected, 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 reflected. Real image formed at the point F, principal focus. This is concave mirror. Convex mirror, this is principal axis, this is pole. Reflected away. Extend all these things. It appears to come from. Actually, you are not getting it. This is other side of the mirror. No? You will not get any image at all. So the name virtual image. Convex mirror means virtual image. So generally, spherical mirror means it is a part of a sphere. Part of the sphere, one part. Either this side or that side. Any one part of the sphere. Of course, we can prove there is a relation connecting focal length and radius of curvature. We can prove R is equal to 2F. Radius of curvature is twice the focal length. R is equal to 2F. RF is equal to R by 2. Right. Next one. Generally, in the case of a mirror, you are placing an object. Object can be placed beyond 2F. Object can be placed at 2F. Object can be placed between F and 2F. Anywhere you keep the object. That object distance we call it as U. This is object distance. V we call it as after getting the image. V is called image distance. Image distance. F is called the focal length. We can find the relation between these two. Using focal length, we can find the relation. 1 by F is equal to 1 by U plus 1 by V. This is called a mirror formula. For concave mirror and convex mirror, both we can achieve. Mirror formula 1 by V plus 1 by U is equal to 1 by F. Correct? Next. Lateral displacement. Full of ray diagram only, ma. In the case of light chapter, carefully we have to say this is a glass slab of thickness T. We are going to just define what is lateral displacement. That's all. Say this is normal. Perpendicular. Light is incident. This should be the actual path. This is air medium. This is glass, denser medium. Now light is bending towards the normal. Light is bending towards the normal. Bends towards. Now from glass again it goes to air. Bends away from the normal. So this is the actual direction of light, but this is the incident ray direction. You are extending by a dotted line. This is actual light direction. So this is called L, lateral displacement. Lateral displacement. Okay. Refractive index, you can write here 1 mu2. 1 mu2 means mu2 by mu1. Refractive index of the second medium by refractive index of the first medium. Sir, I need a relation between the speed of light and refractive index. We can write refractive index mu is equal to speed of light in air or vacuum divided by speed of light in a medium. Speed of light in air or vacuum. What is the meaning? Mu is equal to C. C is called velocity or speed of light in air. V is called velocity of light in medium. We have one formula here. Velocity, frequency, wavelength. We have a formula. C is equal to mu lambda. Nu is called frequency of the incident ray. Lambda is called the wavelength. When light travels from one medium to another medium, frequency of light remains constant. Velocity changes, wavelength changes, but frequency of light remains constant. So I can write here C is equal to mu. This is air medium, so I am writing lambda air. Then nu lambda medium, lambda m. Nu get cancelled. I can write mu is equal to lambda air by lambda mu. Either you can write mu is equal to C by V, or you can write mu is equal to lambda r by lambda medium, which is a constant. Numerator is wavelength, denominator is wavelength, it is a constant. Numerator is velocity, denominator is velocity, that is a constant. It is a ratio, no unit. Very well, you know, velocity of light in air is more than that of velocity of light in tensor medium. It is experimentally proved by one scientist. Velocity of light in air medium is more than that of velocity of light in tensor medium. It is proved. So, numerator C is greater than V. So, always mu is greater than 1. Refractive index of the given medium is always greater than 1 because velocity of light in air is greater than velocity of light in a medium. Correct? Basic information.